Alex Lawrence Barkley at the inaugural MediSens conference here in Docklands, London. I'm with Richard Harvey of Hamamatsu, and firstly, welcome along to MediSens.
Thank you very much.
And how have you found the conference so far?
Oh, it's been excellent, actually. It's been very good, very enjoyable.
So Hamamatsu is a company that makes sensor chips, is that right?
That's correct, yes. We make sensor chips, but we also make vacuum tube detectors, which are the sort of the precursor to the current technology, and we also make complete systems as well for the end users.
Right, and what about the topics at the conference that you've experienced so far? Have you been into many sessions?
I've been to all the sessions, yeah, and they've been very interesting. In particular, the ones on PET and the combination of PET with CT and PET with MRI as well have been particularly interesting to us.
Right. Okay, so is that because the sensors that are being talked about in those sessions are relevant to specifically your area of expertise or business?
Absolutely. So the detectors which enable you to do PET plus MRI, these silicon photomultipliers which we're showing today, internally we call it MPPC, which is just our kind of brand name for it. But it's a silicon technology based on avalanche photodiode, but you array these up with a common output. But what it allows you to do is essentially photon counting at room temperature, and it's insensitive to magnetic fields. So with an MRI scanner, you have very, very high magnetic fields, 3, 4, 5 Tesla, even higher. And with the traditional photomultiplied tube technology, that just doesn't work. You can't combine that detector with an MRI machine. But with these silicon PMs, because they're insensitive to magnetic fields, you can combine that with the high magnetic field of the MRI, and you have multimodality imaging. So that's really the key enabler.
And you mentioned at room temperature. Why is temperature a limiting factor?
Particularly not just in sort of medical imaging, but in general applications where you're measuring very, very low levels of light. Higher temperature means higher noise, and higher noise means you can basically measure less signals. It's also your signal-to-noise ratio. If you cool things down, then you can get better signal-to-noise. However, the silicon PM now, the signal-to-noise ratio, even at room temperature, is good enough to do single photon counting.
Right, and what sort of devices are these type of sensors going into?
So the idea and the plan is that they will go into the full scanners. So this is preclinical scanners and into human scanners as well. But they're also actually usable in a wide range of applications beyond the medical. So the first people to use these were in the high energy physics market. So this is academics in the big collider experiments. So initially it was avalanche photodiodes, but now they're shifting towards this technology down at CERN, for example. But also for things like range finding, so LiDAR in the automotive sector, that could also use this technology.
Talk us through what we've got here.
So this really just showing a range of the different packaging options. So all of these devices here are just single element detectors. So these would conventionally be used in, say, something like fluorescence detection. They could be used in range finding. The actual devices which we use in medical imaging are such as this. So this is an 8x8 array of silicon photomultipliers.
So rather than having one individual sensor, you've actually got 64 sensors on there.
Yeah, and that basically allows you to build up a camera effectively. So these are effectively pixels in a camera, but they're just very, very large. And maybe you can't see on the camera, but in the center of each channel is a little white dot, and that's your TSV. So we're using this through silicon via technology, which allows you to do 4-side buttable detectors, so you can build these up to any size you wish. So you see here we have a 4x4, which is very small, 8x8, but we can also do 16x16. We can do linear arrays, and then there's no reason why you couldn't do other shapes as well if you so wished.
Right, so you're talking about a sensor that's about an inch square roughly, and it's only got 64 pixels, but it's that low resolution because it's looking for extremely low energy volumes of particles coming back.
This one here is an example where you actually have 1x1 millimeter, so you can see it's the same form factor, but a lot smaller channels. That just gives you high resolution. But what would typically happen in the scanner is you'd build these up into a big ring around the patient. So you wouldn't just have one of these; you'd have a whole ring. You'd have multiple banks of these detectors, and then you'd couple a scintillator to this as well, which then improves your resolution as well. So you'd have segmented scintillator crystals. You could do dual layer segmented to increase resolution further as well.
Right, so for those people who are not in the know and not in this particular industry, this is the stuff that is essentially the ring that you see people being fed into in an MRI scanner is a giant camera, and the ring itself that all goes all the way around is the sensor that gives you the pictures.
Absolutely, yeah. So on a PET you have a whole ring, and you can see essentially here this little schematic. You have the patient surrounded by a ring. So traditionally that would have been Hamamatsu photomultiplier tubes. now that people are moving to Hamamatsu silicon PMs.
At Hamamatsu, are there any other particular technologies or groups within the company that you think have got something to offer the medical sector? Obviously, it's a big company making sensors in lots of different areas. You mentioned automotive as well. I mean, do these types of sensors also apply? Is the same R&D used in other areas as well?
Absolutely, yeah. So particularly in Europe, the largest market of Hamamatsu is in the medical. So we have a lot of business in dental, for example, so dental X-ray. But really, medical is the key application area. But it varies from division to division and by country to country as well. Certainly, the silicon PM, which we're showing today, is a key technology for the future. But some of the more traditional technologies that we've been manufacturing for 50 years are still used prevalently today. And they enable things like they were going into systems for blood detection or blood analysis, urine analysis, blood gas detectors. So it's really the whole product range that we manufacture can be used in medical, but it can also be used in other application areas completely separate to that as well. So which is why we're saying this can be used in medical. It can also be used in the automotive sector. So they're very different, but they can both benefit from the technology.
Right. And just talking again about the conference and our surroundings here, have you enjoyed the conference so far?
No, it's been absolutely brilliant. It's the quality of the people who actually came and the people who are doing the talks has been fantastic, and particularly as this is the first year, then I think it shows it's going to be a good conference going forward as well, so we're looking forward to attending again.
Great, well hopefully you'll come back next year and we'll look forward to seeing you.
Thank you.
Thank you very much for your time.